Okay, so today we're going to dive into something pretty wild.
Hmm.
Google's new quantum computer
Yeah,
called Willow.
that's right.
And it's making some pretty big waves.
It
A
is.
lot of headlines are even saying that it could like simulate the multiverse.
Yeah, definitely pushing the boundaries.
So we're basing this deep dive on an article,
Okay.
and it's called Google's New W Quantum Computer Changes Everything.
Catchy title.
Right. And it really kind of lives up to the hype, I think.
Yeah, I think so.
So one of the things that really stood out to me
Okay.
was just how far we've come. You know,
Yep.
it all started back in 1900
Right.
with Max Planck,
Max Planck, that's right, quantum theory.
quantum theory.
Yeah.
And now we're here
And now look at us.
with Google claiming this, like,
Quantum leap.
quantum leap
Yeah.
in computing power.
Exactly.
It's not just science fiction anymore.
No, it's becoming very real.
Like, this is real deal stuff.
Yeah.
So this article highlights how Willow can do calculations in like 5 minutes. That would take the world's fastest supercomputers
Yeah.
10 septillion years.
Yeah, think about that for a second.
That's a 10 with 25 zeros after it.
It's just mind-boggling, the scale of that.
It's insane.
Yeah.
So,
It really highlights the difference in processing power.
like, what is quantum computing?
Right. So it all boils down to
Yeah.
quantum mechanics,
Yeah.
which are basically the rules that govern the really tiny stuff.
Okay.
So instead of bits,
Yeah.
which are those zeros and ones.
Yeah, the ones and zeros in regular computers.
Yeah, exactly.
Yeah.
Quantum computers use qubits.
Okay, clean.
And these qubits are wild.
Okay.
They can be in a superposition,
Superposition.
meaning they're both 0 and D1 at the same time.
Wait, so how can something be two things at once?
Yeah.
That's like saying my cat's both asleep and chasing a laser pointer.
It is mind-bending. It's hard to wrap your head around.
Yeah.
But that's the beauty of quantum mechanics.
Okay.
And then there's this thing called entanglement.
Entanglement.
Yeah. Where things get even weirder. We can imagine two qubits linked together, even if they're miles apart.
Okay.
Whatever you do to one instantly affects the other.
Yeah.
And this is what gives quantum computers their crazy power.
So Willow uses these qubits.
Yes.
And it does what exactly?
Right. So what's special about Willow
Yeah.
is that it tackles a major roadblock in quantum computing.
Mm-hmm.
And that roadblock is error correction.
Error correction.
You see, qubits are super fragile
Okay.
and prone to errors.
Uh-huh.
And as you add more qubits,
Yeah.
these errors multiply,
Okay.
making it really hard to build larger quantum computers.
So it's like a house of cards.
Yeah, kinda.
The more you add, the more unstable it gets.
Exactly.
Okay.
But Willow uses something called topological qubits,
Topological qubit.
which are way more stable.
Oh, okay. So that's the key.
That's the key. This is huge E.
So they found a way to make these like finicky qubits
Yes.
behave.
Exactly.
And now they can like build bigger
Yes.
and better
Yeah, much bigger.
quantum computers.
More powerful quantum computers.
That's pretty impressive.
It's a significant leap forward.
Yeah.
And it has major implications,
Okay.
especially when we start talking about artificial intelligence.
Oh, yeah. AI.
That's right.
I've heard that quantum computing could like supercharge AI.
Oh, absolutely.
How's that work?
Well, AI thrives on data, right?
Yeah, the more data, the smarter it gets.
The more data it can process, the smarter it gets.
Yeah.
And quantum computers can chew through data at warp speed.
Okay.
We're talking potential breakthroughs in machine learning,
Mm-hmm.
predictive modeling, drug discovery,
Yeah.
anything that needs to crunch massive data sets.
So we're looking at AI that's not just smarter, but exponentially faster,
Exactly.
thanks to these like quantum number crunchers.
That's right.
Now, I know a lot of folks are probably worried about quantum computers
Sure.
and their potential to like break all our encryption
Yeah.
and steal our data,
That's a valid concern.
especially when it comes to like Bitcoin
Yeah, that's right.
and blockchain security.
Yeah.
What's the article say about that?
So cracking Bitcoin's encryption is theoretically possible
Okay.
with a quantum computer,
Uh-huh.
but you'd need a machine with over 1 million qubits.
Okay.
Willow has 105.
Okay.
So we're a ways off from that scenario.
Now, Bitcoin might be safe for now.
For now, yeah.
But what about like
However,
our passwords,
Yeah.
our bank accounts?
the article does point out that systems like Google Chrome passwords, even ATM security, are more vulnerable
Oh, no.
in the near term.
So are we doomed to a quantum hacking apocalypse?
Not necessarily.
Okay.
Researchers are already developing something called post-quantum cryptography,
Post-quantum cryptography.
or PQC for short.
PQC.
Okay. This involves creating new encryption algorithms that are designed to withstand attacks from even the most powerful quantum computers.
So it's like a race.
It is a race.
To develop these quantum-proof security measures before quantum computers get powerful enough to crack the current ones.
That's right.
Okay, so it's a race we need to win.
It's a race we absolutely need to win.
All right, so we're not defenseless.
Not yet. Yeah.
Good to know.
Yeah.
Now, the article mentions a couple of big names in the quantum world.
Okay.
Hartmut Neven,
Yes.
the founder of Google Quantum AI.
That's right.
And John Preskill, a renowned physicist.
Yes, a very smart guy.
What are their thoughts on Willow?
Okay, well, John Preskill, he points out that while quantum hardware is still a work in progress and it produces errors, they've managed to overcome this by running Willow millions of times.
Oh, wow.
In a matter of minutes.
Okay.
So basically leveraging its sheer computational power
to
find the right answer amongst the errors.
So they're just letting it run wild?
Kind of, yeah.
Knowing they'll get enough accurate results to be useful?
Exactly. They're using probability to their advantage.
Clever.
Yeah.
What about this random circuit sampling thing? I keep seeing that mentioned.
Random circuit sampling, or RCS for short.
RCS.
It's a benchmark used to gauge the performance of a quantum computer.
So like a speed test?
Yeah, like a speed test, exactly.
Okay.
It involves running a specific type of random program on the quantum computer and comparing its performance to a classical computer.
And Willow aced that test?
Oh, absolutely blew it out of the water.
Okay.
Hartmut Neven emphasized how Willow outperforms the best supercomputers we have.
Wow.
In terms of both speed and efficiency.
Okay, so Willow is a beast.
It's a beast.
Fast.
Yes.
Accurate.
Very accurate.
And it's paving the way for even more powerful quantum computers.
That's the exciting part.
So this is all very cool.
Yeah.
But why should our listener care about any of this?
That's the million-dollar question, right?
Yeah, how could this technology actually impact someone's life?
Well, the implications are vast.
Okay.
And quite frankly, mind-boggling.
Okay.
We're talking potential revolutions in medicine, logistics, science, finance, cryptography.
Well, okay, break it down.
Yeah.
What kind of real-world impacts are we talking about?
Let's start with medicine.
Okay.
Imagine being able to simulate the interactions of molecules at the quantum level.
Yeah.
This could lead to the development of new drugs and treatments for diseases that are currently incurable.
That's incredible.
It is.
Like using quantum computers to create life-saving medicines.
Exactly. In logistics,
yeah,
we could have incredibly efficient supply chains and delivery routes, saving time and resources.
That makes sense.
In science, quantum computers could help us unlock the mysteries of the universe by simulating complex physical phenomena. And in finance, we could revolutionize risk management and investment strategies.
So it sounds like we're on the cusp of
a new era.
A new era.
A quantum era.
A quantum era.
With possibilities we can barely even comprehend.
Okay, I'm officially mind blown. We've covered a lot.
Yeah.
What are the key takeaways here?
All right, so key takeaways.
Yeah.
Number one, Willow's breakthrough in error correction, using those topological qubits, is a game changer.
Okay.
It paves the way for larger, more powerful quantum computers.
Right.
That will undoubtedly have a major impact on our world.
Absolutely. And we can't forget about post-quantum cryptography.
That's right.
We need to start preparing now.
Yes.
For the security challenges that quantum computers will bring.
Absolutely. We need to be proactive.
And lastly,
this is just the beginning. The potential of quantum computing is so vast, we're only just starting to see its true capabilities.
So for our listener out there, is this going to be as big as the internet?
It's a question worth pondering.
Yeah.
Could quantum computing reshape our world in ways we can't even imagine yet?
It's pretty crazy to think about.
It is.
While you're thinking about that.
Yeah.
I encourage you to dig a little deeper into post-quantum cryptography.
Yeah.
And what it means for your own digital security.
Good advice.
Okay, that's it for part 1.
All right.
Of our deep dive into the world of quantum computing.
See you next time.
Join us next time as we'll explore even more.
Buckle up.
So last time we were talking about Google's Willow chip.
Yeah.
And how it's kind of like shaking things up.
It's literally shaking things up.
In the world of computing.
Yeah.
We were exploring those like mind-bending principles.
Right.
of quantum mechanics.
Like superposition.
Superposition.
Entanglement.
All that good stuff. And then we even talked about some of the, like, ripple effects that quantum computing could have on, like, everything from medicine to financial markets.
Right. It's going to touch everything eventually.
So?
But I think it's time to kind of shift gears a bit.
Okay.
And think about some of the bigger societal implications.
Okay, so let's get into that.
Yeah, let's talk about what are some of the things we should be thinking about?
Yeah. As this technology becomes more widespread.
Like, what are some of the things that could happen?
Well, one of the big things is access.
Access, okay.
Quantum computing is incredibly complex.
Yeah.
And expensive.
Yeah, I can imagine.
So naturally, one of the concerns is that only the wealthy and powerful will be able to benefit from it.
So kind of like widening the gap between the haves and the have-nots.
Exactly.
But this time, it's about access to this crazy technology.
Right. It's a new kind of digital divide, potentially.
Yeah. We really have to be careful about that.
We do. And we need to be mindful to ensure that the benefits of quantum computing are available to everyone.
Right.
Not just a select few.
Yeah, otherwise we're just creating more problems.
Exactly. Exacerbating existing inequalities.
Right.
And that's not what we want.
Okay, what about jobs?
Oh, that's a big one.
Yeah. People are already worried about AI taking over jobs.
Sure.
Is quantum computing going to make things even worse? Well, it's true that quantum computing has the potential to automate many tasks that humans currently perform.
Right.
But I don't think it's necessarily a doom and gloom scenario.
Okay.
While some jobs will inevitably be displaced,
right,
quantum computing will also create new opportunities and entirely new industries.
So it's not just about job losses.
No.
But also about job evolution.
Exactly.
The workforce needing to, like, adapt
and acquire new skills. That's why it's crucial to start thinking now about how we can prepare the workforce for these changes.
Okay, so education and training.
Retraining programs that focus on the skills needed to thrive in a quantum-powered world.
Yeah, okay, so we've talked about access, we've talked about jobs. What other kind of societal impacts are you thinking about?
Well, another area worth considering is security.
Okay, security. We talked about post-quantum cryptography.
Right, we did. But we need to think beyond that as well.
Beyond just, like, protecting our data.
Right, because quantum computers could be used for malicious purposes.
Oh, no.
Like breaking encryption on a massive scale.
Okay.
Or disrupting critical infrastructure.
So protecting, like, power grids.
Tower grids, communication systems, all the things that keep society running.
Yeah, we got to think about that.
We do. We need to start thinking now about how to safeguard these critical systems against potential quantum attacks.
Yeah.
It's a huge challenge, but one we need to address proactively.
Okay, so a lot to consider here.
Yeah, definitely.
Any upsides?
Oh, there are definitely upsides. In fact, I believe quantum computing has the potential to help us solve some of the world's most pressing problems.
Like, what? Give me some hope here.
Okay, how about climate change?
Climate change, okay.
Quantum computers could help us develop new sources of clean energy.
Okay.
Optimize resource allocation.
And even create more accurate models of the Earth's climate system.
So maybe we can use quantum computing
potentially
to combat climate change.
Yes.
Okay. What else?
We could accelerate drug discovery. Create personalized medicine.
Wow.
And even advance our understanding of the universe itself.
Okay, so it's not just about risks and challenges.
No.
But also about opportunities.
Absolutely.
So, like, improve the world.
That's the exciting part.
This is a lot to wrap my head around.
It is a lot to digest.
Yeah. It's not every day we talk about technology that could, like, reshape the world as we know it.
That's why it's so crucial to have these conversations now.
Yeah.
Before this technology becomes even more powerful.
Right.
And ubiquitous.
So we need to be proactive.
Absolutely.
And start thinking about the implications of quantum computing today.
Yes.
Even if we don't have all the answers.
Exactly. We need to anticipate the challenges, embrace the opportunities.
And above all, ensure that this technology is used responsibly and ethically for the benefit of all humankind.
That's a good point.
Yeah, it's not just about technological advancement. It's about how we use it.
Yeah.
And what we do with it.
Okay, now I'm really curious about those mind-blowing possibilities.
Oh, you want to get into the science fiction stuff?
Yeah, the ones that sound like straight out of science fiction.
Like quantum teleportation.
Quantum teleportation.
Simulating the universe itself.
Buckle up, everybody, because we're about to go deep into the quantum rabbit hole.
That's right.
Okay, so we're back, And I'm ready to dive into some of that like science fiction stuff.
All right, let's do it.
Quantum teleportation.
Yeah, quantum teleportation.
Are we talking about beaming people up, Scotty style?
Not quite.
Okay.
Good. Anyway, good. It's not about teleporting matter.
Okay.
But rather about transferring quantum information instantly.
Okay. So not people, but information.
Right.
Still sounds pretty wild, though.
It is pretty wild.
How does that even work?
Imagine you have two entangled particles.
Okay.
One here on Earth and one way out on Mars.
Okay. Two tiny particles, billions of miles apart.
Exactly. And remember, entanglement means they're linked no matter how far apart they are.
Yeah, they're connected.
Right.
Right.
So what happens? You perform a measurement
Okay.
on the particle here on Earth.
Uh-huh.
And this measurement instantly changes the state of its entangled partner on Mars.
Okay.
Effectively teleporting the information.
Wow.
From one to the other.
So it's like sending a message.
Yeah.
But without signals or delays.
Exactly. It's instantaneous.
That's insane.
Pretty mind-blowing, isn't it?
What could we use that for?
Well, think about secure communication.
Okay, yeah.
With quantum teleportation, you could send information across vast distances instantly and with complete security.
Secure and instant.
Because it's impossible to intercept.
Wow.
Or eavesdrop on.
Okay, that's amazing.
Yeah.
What else can these quantum computers do?
How about quantum simulation?
Quantum simulation.
Yeah, imagine being able to simulate anything.
Anything.
From the behavior of molecules to the evolution of the universe itself.
So like creating a virtual universe.
In a way, yes.
Inside a quantum computer.
Yeah, it's like a universal simulator.
Is that even possible?
Theoretically, yes.
Wow.
We could use quantum computers to model incredibly complex systems in ways that are just impossible with classical computers.
Okay. And what would that allow us to do?
Well, it could revolutionize fields like material science.
Okay.
Where we could design new materials with specific properties or drug discovery, where we could simulate how different drugs interact with the human body at the molecular level.
It's like having a super-powered microscope.
Yeah, kind of.
That lets you see and manipulate the building blocks of reality.
Exactly.
Now, you mentioned simulating the universe.
Yes.
Could quantum computers really help us understand the universe better?
Absolutely.
How so?
They could help us tackle some of the biggest questions in cosmology.
Yeah.
For example, simulating the conditions of the Big Bang,
Right.
or even exploring the possibility of the multiverse.
Hold on, the multiverse? Like other universes out there?
That's one of the most mind-bending implications of quantum mechanics.
Okay.
The idea that our universe might be just one of many.
Wow.
Branching off with every quantum measurement.
And quantum computers could help us explore these other realities.
Potentially, yeah.
Yes.
That's pretty wild.
It is wild stuff.
So much to think about.
But let's step back for a second.
Okay.
We've talked about some incredible possibilities.
Yeah.
But what about the reality?
Yeah, where are we?
Where are we on this journey?
Yeah.
The field is moving at an incredible pace. New breakthroughs are happening all the time.
Okay, so it really feels like the future is quantum.
It certainly seems that way.
Yeah.
Quantum computing has the potential to fundamentally change the way we live, work,
and understand the world around us.
It's been a wild ride.
It has been a wild ride.
Exploring the world of quantum computing.
It's a fascinating field.
Yeah.
And we're just scratching the surface.
Exactly. And as we step into this new quantum era, it's important to remember that this is just the beginning.
Absolutely.
There's still so much to discover and explore.
So stay curious. Keep asking questions.
Yeah.
And never stop imagining the impossible.
Because in the realm of quantum computing, the impossible might just be a qubit away from becoming reality.
That's a great way to put it.
That's a great note to end on.
Yeah.
Thank you so much for joining us.
It's been a pleasure.
On this deep dive into the world of quantum computing.
The pleasure was all mine.
It's been a pleasure talking to you.
Likewise, until next time.